Nicotine dependence is caused by an interplay between environment and genes. The age at which one smokes their first cigarette is reflective of the environment that an individual grew up in. The sense of urgency to smoke has more to do with genetic variations. Individual habits like drive and tolerance also play into how likely one is to develop nicotine dependence. Around two-thirds of young people have tried a cigarette, but only around 20% become dependent smokers. A genome-wide association study of nicotine dependence found 35 significant SNPs across the genome that marked 14 genes. Nicotine dependence has a clear effect on neurotransmitters, which are found in the brain. Much of the negative emotional side effects of nicotine withdrawal are tied to the protein known as beta-2 nicotinic acetylcholine receptor. The proteins alpha-5 and alpha-7 are connected to the physical side effects of nicotine intake levels. These receptors, known as NACHRs, respond to the neurotransmitter ACH, which is a compound that works throughout the nervous system but functions as a neurotransmitter. So it makes sense that the changes in these proteins that affect compounds like the nervous system would affect the likeliness of nicotine dependence.
When it comes to predicting nicotine dependency, there are two genes that have shown indications of increased risk. These two genes are the OPRM1 gene and the CHRNA3 gene. The role of the OPRM1 gene is to provide instructions for the mu1 opioid receptor within the endogenous opioid system. This system is in charge of regulating pain, reward, and addictive behaviors. The mu receptors are the primary receptor for beta endorphins and enkephalins, as well as outside-the-body opioids called exogenous opioids. The CHRNA3 gene is responsible for creating a specific subunit, the alpha-3 subunit, of certain nicotinic acetylcholine receptors. Genetic studies have identified single nucleotide polymorphisms, aka SNPs, within the gene cluster containing CHRNA5, A3, and B4 that have shown risk factors for nicotine dependence as well as lung cancer. There will be 10 SNPs being tested within the SNP chip test. There are two specific SNPs that are particularly important to look out for. These two SNPs are the RS104-85057 and the RS105-1730. The RS104-85057 SNP is found on the OPRM1 gene, while the RS105-1730 SNP is found in the CHRNA3 gene. The possible genotypes for the RS105-1730 SNP is being homozygous for the C allele, being homozygous for the T allele, or being heterozygous of both the C and T allele. The homozygous C allele genotype would indicate normal nicotine use, while the homozygous T allele genotype would indicate a 1.8 times increased risk of nicotine and lung cancer. Heterozygous of both the T and C allele would be a 1.3 times increased risk. As for the RS104-85057 SNP, someone can be homozygous for the A allele, homozygous for the G allele, or heterozygous with both the A and G allele. Being homozygous for the A allele and being heterozygous for the A and G allele would indicate a normal risk for smoking and nicotine dependence. Being homozygous for the G allele would show an increased risk for smoking and nicotine dependence.
There are many positives to taking a SNP chip test to look for an increased risk in nicotine dependence. There are scientific benefits as well as personal ones. Knowing whether you are more likely to become dependent on nicotine is important and might stray people from starting in the first place or causing them to make lifestyle changes earlier in life. Also, a SNP test is a great option as one test can do about 1 million genetic tests all at once in only 16 hours. This test is able to identify changes on one's genome at a higher resolution than many other chromosome gene tests. In all, these tests have a lot of benefits and are a good choice for someone looking to find out if they have a higher chance of becoming more dependent on nicotine. Although there are many positives, there are also drawbacks to take into account while deciding if you want to go ahead with a SNP chip test. One of these limitations is that the result of SNP chip tests might become inflated, thus causing a certain amount of false positive rates. So it is important to understand it might be not as accurate. These problems all come back to the P level, which might not reach the significance level needed. The P level is the probability which the test is accurate, and it is possible with these types of tests to get a P level lower than needed, thus making it inaccurate. So all should ensure that they know the risk, that this test might not be perfectly accurate before taking it and believing when they get their results.
It is important to consider the ethical ramifications of predictive genetic testing financially and emotionally. If one were to test positive for our test, the patient would be at increased risk of becoming addicted to cigarettes as well as other tobacco products. While a positive test might deter someone from trying a product, the ethics behind how the test could be used are questionable. This test could be a detriment to someone's finances. For example, insurance companies could require this test before giving coverage to a customer. A positive result could result in decreased benefits, increased premiums, or no coverage at all. We must also consider the emotional toll a positive test could cause. A positive result could make a person feel as though they have no control of what their genes have already predicted, which in turn leads to self-doubt and anxiety over the future. In one case, a 55-year-old woman on dialysis was shown to be a carrier of a dominant genetic disorder. When all 4 of her sons tested positive, 1 out of 4 of them used this information to live life to the fullest, while the others made decisions based on how they thought their life would turn out anyways. These implications should be carefully considered before deciding to take our test, as well as any other predictive genetic test.